FluoRender tutorials. Handling different data formats. Part 1. Image slices. To load image slices as a volume channel, first click the Open Volume button. This sample dataset is one volume saved as a sequence of TIFF files. Select just the first file of the sequence and then check Read a sequence as Z slices in the Additional options. Click Open to load the sequence. FluoRender determines the order of the slices based on the numbers and file names. Part 2. Time sequence. Click Open Volume button to load a time sequence. This example dataset is a series of TIFF files, each a time point of volume data. Set the time sequence identifier to match that of the sequence. In this case, it is _T. Select just the first file of the sequence and click Open to load the data. If the time sequence is identified correctly, the Time Sequence option is checked in the Record/Export panel. Click the Play button to view the time sequence. Click the Play button again to stop the viewing of the sequence. Click the Rewind button to view the first time point. You can also use the plus and minus buttons to step over time and view the sequence. You can set the playback range to a subset of the sequence. For example, in the range of from 0 to 10. The playback is then restricted within the specified range. You may need a high-end computer hardware configuration to achieve interactive viewing speed for time sequence data. Part 3. Olympus Microscopy formats. Select a file of the Olympus binary format directly to load the data into FluoRender. FluoRender determines data size and channels from the metadata of a file of the Olympus format. There's a second Olympus Microscopy format that saves images in a separate folder. Select the index file only to load the dataset. FluoRender determines size and channel information from the metadata as well. FluoRender sets channel colors according to their wavelengths read from the metadata. You can change the color mapping in the settings, such as setting the channel of wavelengths above 633 nanometers to white. You need to reload the data to see the result. Now the third channel is loaded and assigned with the white color. Part 4. Zeiss Microscopy formats. Select a file of the Zeiss format directly to load the data into FluoRender. FluoRender determines data size and channels from the metadata of a file of the Zeiss format. You can also load a time sequence in Zeiss format directly. Click the Play button to view the time sequence. Part 5. Prairie Microscopy formats. A Prairie Microscopy dataset is saved as one XML file and multiple TIFF files in one folder. Select and open just the XML file to load the dataset. FluoRender determines data information including size, channel, and time points from the XML file. Part 6. ImageJ Hyperstack Formats. You can convert an unsupported format by FluoRender to an ImageJ Hyperstack TIFF file with Fuji. For example, this Nikon Microscopy format is not directly supported by FluoRender. When open it in Fuji, select Hyperstack for the option View Stack With and leave other options to defaults. Click Open to load the data. Wait until the Nikon data file is loaded into Fuji. This dataset contains 2 channels of volumes and time points. Save the dataset as a TIFF file, which contains all information necessary to interpret the Hyperstack. Close Fuji and load the TIFF file into FluoRender. The channels and time points are correctly loaded by FluoRender. Part 7. Streaming. You can enable streaming for data too large to render. Open the Settings window and in the Performance tab check Enable Streaming. For streaming settings, you can choose the update order when data bricks are rendered in loops. Set the size of your graphics memory that can be used for storing data bricks. The size of a dataset that will be broken into bricks. The size of the brick. And the target response time for rendering. Click Done to apply the changes and close the setting window. With the streaming mode turned on, data loaded subsequently will be broken into bricks and rendered sequentially. Let's open a dataset of large spatial resolutions. Click Open Volume and load the dataset. You can use all the available user interactions to view this dataset. Notice that the update of the visualization may be progressive during user interactions. For large spatial resolution data, the streaming mode allows zooming in to the fine details. Another type of large data contain a large amount of channels, although each channel has normal spatial resolutions. For such data, we may set a very low data size number in the streaming settings and still visualize the data with streaming. Select all TIFF files in the Open Volume window to load an anatomical atlas composed of 96 channels. You can check the option to skip empty bricks if some channels contains power structures. Click Open to start loading the dataset. It may take some time to load all the channels. Do not interrupt file reading until all channels are loaded. Now, we can see that all channels are loaded and visualized with FluoRender. You can use all the available user interactions to view this dataset. Notice that the update of the visualization may be progressive during user interactions.